Hello and welcome to this Python tutorial and welcome to part 9, dimensionality reduction. So we are starting this part with our first technique of dimensionality reduction, which is PCA, principal component analysis. And so in dimensionality reduction there are two techniques, feature selection and feature extraction. We did feature selection in part 2 when we implemented the backward elimination model to select the most relevant features of our matrix of features, that is, the features that explain the most the dependent variable, and now we are starting this new technique of dimensionality reduction, which is feature extraction. And PCA, principal component analysis, is one feature extraction technique. So as a reminder, let's say your matrix of features has m independent variables. Well, what PCA will do is that it will extract a smaller number of your independent variables, but that are going to be new independent variables, like new dimensions. And these new independent variables extracted are going to be some new independent variables that explain the most the variance of your dataset. And that is regardless of your dependent variable. And that makes PCA an unsupervised model, in the sense that we don't consider the dependent variable in the model. So that's PCA, and remember in part 2 and part 3 we worked with one or two independent variables. Well, that was for two specific purposes. The first purpose is that we needed a graphic visualization of our results, and since each independent variable corresponded to one dimension in the plot, well, we could visualize our results with at most two independent variables. And the second reason is that thanks to this PCA dimensionality reduction technique, well, even if we have a lot of independent variables at the beginning, well, we can end up with much less independent variables, but that are going to be relevant independent variables, because these independent variables will explain the most the variance of your dataset. And therefore, since we can reduce this number of independent variables, well, we can end up with 2 or 3 independent variables and therefore visualize the results as we did in part 3. And this is exactly what we're going to do in this tutorial and the following tutorials of this section and the following sections when we cover other dimensionality reduction techniques like LDA and also kernel PCA. Well, we will have many features at the beginning and therefore it will be impossible to visualize the results. But then when we apply PCA or LDA, we will reduce the number of features down to 2 and therefore we'll be able to visualize the results. So let's start right now and let's go to our File Explorer window to find our working directory folder. So right now I'm on my desktop, Machine Learning AZ. We are now in part 9, dimensionality reduction. Here we go. And we are starting with this first technique of dimensionality reduction, principal component analysis, PCA. And that's the folder we want to set as working directory. So make sure that this folder contains the wine CSV file, and if that's the case, you are ready to go. Okay, so I also opened this logistic regression.py file that we made in part 3 classification, because you're going to see that we are going to deal with a classification problem, and basically what we're going to do is use this logistic regression model to solve this classification problem, but we will apply PCA inside this logistic regression model so that we can end up with 2 independent variables that explain the most the variance. And therefore we will be able to use these code sections here that visualize the results. So what I'm going to do now is take everything from the bottom up to the top, copy, and paste it here in my pca.py file. And now we will change a few things, and mostly we will implement PCA. Okay, so the first thing that we need to change is the name of the dataset. We're no longer working with the social network ads CSV file. We are working with the wine.csv file. So wine.csv. Okay, perfect. So I'm going to explain the business problem afterwards. And so now we are going to import this dataset, and I'm going to explain the business problem behind this. So let's first import the libraries. Here we go, done. And now let's import the dataset. So I'm selecting this line and executing. Here we go. And now let's go to Variable Explorer. the dataset is well imported. Let's have a look. Okay, so first of all, this is a very famous dataset, well known in the machine learning literature, and that you can find on the UCI machine learning repository, as you can see here, and you can find this page at this link. So basically, first, what are the independent variables and what is the dependent variable? Well, the independent variables are all the variables from this one, alcohol, up to this one, proline, and this last variable, customer segment, is the dependent variable. So in the original dataset, this dependent variable is not called customer segment. This is actually the origin of the wine. But let's imagine that we, as data scientists, are working for a wine business owner, and this wine business owner gathered all these informations in this dataset. And so first, what this business owner did is that it gathered all the informations of these independent variables here, that are chemicals informations of several wines, and this business owner applied some clustering technique to find some segments of customers that like a specific wine depending on the informations of the wine. And by applying these clustering techniques, this business owner identified 3 segments of customers. That's the first one here. Then we have the second one, and eventually the third one. So based on these informations and thanks to its clustering techniques, well, this wine business owner managed to find some segments of customers, each segment having a specific preference for a specific wine. So basically this business owner found 3 types of wines, each type of wine corresponding to 1 segment of customers, and therefore 3 segments of customers. And why does it create added value for his business? Well, that's because now what this business owner can do is take all these informations of the wines as well as the information about the customer segments and make a classification model like logistic regression in which the independent variables are all these variables and the dependent variable is the customer segment. And therefore for each new wine, it can predict to which customer segment it should recommend this wine. So the logistic regression model that we're going to build is going to return the customer segment that each new wine should be recommended to. So that adds a lot of value for this business owner. But then, if this business owner wants to have a clear visual look at the prediction regions and the prediction boundary of the classification model that we're going to build, to be able to see if the predictions are in the right spot of the customer segment, well, it cannot be done with all these independent variables. Because of course, we cannot represent these many independent variables in one plot. We would need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 dimensions. That's impossible. So what we need to do is apply some dimensionality reduction techniques to extract 2 independent variables that explain the most the variance, and then we'll be able to see the prediction regions and the prediction boundary. And therefore we will clearly be able to see where the customer segments are and where these predictions of the customer segments are according to the extracted features of all the informations of our independent variables. And remember, these extracted features are called the principal components. So let's do this. Let's build our logistic regression classification model and let's apply PCA to reduce the dimensionality of our problem and eventually to visualize the results. So before I close this dataset, let's notice that we need to change the indexes here in the matrix of features as well as the index of the dependent variable. So let's see what indexes we need to change with this dataset. Alright, so this is the matrix of features. We need to include here the indexes of the columns of our independent variables. And so these are the indexes of all the variables from here up to here. And since indexes in Python start at 0, well, that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So this is going to be the range from 0 to 12. But remember that the upper bound in a range is not included. So it will be the range from 0 to 13. And we will type it as 0, 13. And then for the dependent variable, well, that's the index of the last column of this dataset, and therefore that is 13, because this was the index 12, and therefore this index is 13. So now we can click OK and close this, and replace the right indexes here. So here we said 0:13, and here we said 13. And now just be careful, we need to remove these brackets and we are good to go. So I'm going to select this line to create the matrix of features. Here we go, and select this line as well to create the dependent variable. Perfect. We can have a quick look to check. This is the matrix of features that contains our 13 independent variables. Perfect. And now the dependent variable with the 3 categories of wine, each one corresponding to one segment of customers. Perfect. And now we are ready to move on to the next section. So the next section is to split the data set into the training set and the test set. We will need to do this because we want to train our model on the training set and test its performance on a separate test set. And here let's pick 20% of observations going to the test set so that we have 80% in a training set and 20% in a test set. Perfect. So this is ready. We can select this section and execute it to split the dataset into the training set and the test set. Here we have this deprecation warning because I just updated the latest version of Spider, and in this version cross-validation was replaced by model selection. So basically the name of the package has changed, and therefore if I reselect this, the deprecation warning should disappear. And here we go. And now let's move on to the next section. So the next section is feature scaling. And feature scaling must be applied when we apply dimensionality reduction techniques like PCA or LDA. So we're going to select this section as well. We don't have anything to change here. That's all good. That's the beauty of the template. And so execute. Here we go. Perfect. Now our matrix of features is scaled. And then the next section is the section that fits the logistic regression model to the training set. But actually, that is not the next section that we need to run, because right now is when we have to apply our first dimensionality reduction technique, PCA. Remember, you need to apply it right after the data preprocessing phase, so right after the feature scaling step, and just before fitting your logistic regression model or any other classification model for that matter to the training set. So here I'm going to add a new section, and this is going to be applying PCA. Perfect. So let's stop here for this first tutorial, and in the next tutorial we are going to implement PCA and extract these new independent variables that explain the most the variance. So I look forward to doing that in the next tutorial, and until then,